Hi, to write a solution for insertion sort, the first thing we could do is to understand what is insertion. So for insertion to work, you first have to get a sorted array. So we will write our array, our sorting in a way that's going left to right, and every time we point a target value, we must make sure the left-hand side of the target value is sorted. So that's the first concept. The second concept, let's make this unsorted array into symbols so we can understand better by having C smaller than target, smaller than A, and redistribute the array. So our target value, which is 2, is going to compare all the elements that are on the left hand side of it. So we can start with A1 and A1 bigger than target, so we will push the value stored in this position to its right. The same goes to A0, and then by the end of it, when we are checking C is smaller than the target, so we will use this space we clean up and input our target inside. And then when we start with the next target value, the elements inside is left is still sorted. Yeah, let's use the same example that we mentioned earlier to use as our input array. So it's insertion sort, and we pass in the input array here, and then we check the elements inside the input array and check if we have at least 2 elements inside. Otherwise, we return the input array. We need at least 2 elements to compare with each other so we can sort them. Otherwise, it's pointless to do the sorting, right? So we can write a for loop here first and iterate through the array. Pass. All right, we start with 1 because, like I just said, we need to compare the elements on the left with the target value. If our target value is the first elements, there won't be any elements on the left-hand side of it. So we start with index 1, then we store our target value in a placeholder. Because during the process, our target value might be replaced by the elements before it happens. So we store it first. Then we can write another for loop that's going to iterate from right to left, starting with the target value position. So it's going to be j I minus 1 starting and it's supposed to be bigger or smaller than, at least be 0. Then we check for scenarios of input array j is bigger than the input array, our target value, and if so, we execute the block inside the for loop, or otherwise we stop the for loop and we will use this j to get our target position. So we will do the push here by having input array j and store the value inside. So store the value stored in position j and to j plus 1 as well, like this. Right. So by the end of this for loop, we will have our input j. So we will take in this variable and use it to find the position, target position, and store our target value inside. So by the end of this for loop, in this case, this is j, so j plus 1, we will get the target position. Then we pass in the target value we stored earlier in. So I think by now our array is sorted, so we just need to return the input array here. Let's test our solution by invoking the insertion sort, passing the unsorted array here, and passing a copy of it in actually. Then we write no insertion sort and see our array is being sorted. So this solution is actually going to work on negative numbers and 0 as well. So let's run the code again. As you can see, again, our array is being sorted. So basically, this is how you write the insertion sort in JavaScript. Thank you for watching.